Welcome back to the channel. In the previous video, we were looking at circles whereby the center was at the origin. In this video, we're trying to just introduce circles where the center is actually not at the origin. To get into that, remember the standard equation for circles with centers at the origin was derived by using the distance formula. We're going to do a similar thing here. The unfortunate thing is that the coordinates of the center is no longer 0 and 0. It's actually A and B, just like that. But that doesn't bring any problems. So to get r in this case, which is the distance between the center and any point which is on the circle, using the distance formula, in this case we just have an arbitrary center which is called M. That's point M, and we have an arbitrary point on the circle which is P. To get that distance, you can use the distance formula like that. Just substitute, and then you'll have this form, this equation rather. On that equation, you know that MP, as you can see, it's basically your radius. So you can replace MP by R, and then you'll have the standard equation for a circle with center which is not at the origin. So always when you are dealing with circles whereby the center is not the origin, it's not at the origin rather, this is the standard equation that you are always working with. Okay, there's nothing much to say after that. We're just going to do a couple of examples to understand how we can apply that equation. So firstly, let's look at what we have here. We are required to determine the coordinates of the center and the length of the radius of each of the following circles. Of course, we don't see circles here, but these equations, they represent circles. So you can plot them to find those shapes if you want to see them. But in this case, we're just going to deal with the equations. A, we have this circle, or this equation which represents a circle. It's given in standard format. So to get the coordinates of the center, it shouldn't be that much of a problem, because when it's in the standard format like that, the center it's given by just this is A, as you can see, this is B, and then 18 it's R squared. So A it's actually 4, and then B it's actually -3. You just need to change the sign of that. Just basically change these signs, as you can see, to get the center. And then R squared is equals to 18, therefore R is going to be the square root of 18, which is what? The square root of 18, it's actually, let me just do that, is 3 root of 2. That is your R. And then B, suppose you are given the equation in that format, x squared plus y squared minus 6x plus 5y minus 4 equals to 0. You can see it's not in standard format, so we need to get it into the standard format. To do that, or standard form rather, I've been saying format all along, but some prefer to say standard form. So to do that, we just need to firstly group the like terms. Okay, y squared plus 5y equals to 4, and then we move the constant to the right hand side, just like that. After that, what we need to do is to complete the square for x as well as for y. To complete the square, we just take the coefficient of x and then we divide it by 2. That gives us negative 3. That negative 3, we're going to add it on both sides, just like that, and we square it. So that's basically how you complete the square. Even for the y variable, to complete the square, you basically just take the coefficient of y, you divide it by 2, and you square it. Then after squaring it, that term you add it on both sides. Just like here, I just added it to the left. I'm going to add it to the right again. So I added this thing on the left, and I'm adding it to the right again. Then even this one, I'm adding it to the right again. From here, to write this thing in standard format, is just x as a variable. Then you add that value there that you have. That value that we have is -3. X plus -3, that's basically x minus 3, like that. And then y plus 5 over 2, then you square that. Then to get this whole thing, you just need to put everything on a calculator. You'll get a value of 77 over 4. So now you can tell what the coordinates of the center are. Just change the signs. That means you'll have 3 and -5 over 2. And then the radius, r squared, equals to the right hand side, which is 77 over 4. Therefore r equals to the square root of 77 over 4, which is equals to 77, or the square root of that, divided by 2. That is the simplest format you can have. And that is it with B. Then for C, okay, for C, what is happening? Let's get back to the question. As you can see, for C, again, we're given the equation of the circle, but it's not in the standard format. So we're going to make it in standard format, or get it to the standard format. Then we can write the coordinates of the center and get the radius. So to do that, again, we're going to need to complete the square at some point. But let's first rewrite the equation. Plus y squared minus 10y plus 1 equals to 0. So like terms, to some extent, they have been grouped. They have been grouped rather already. So we just need to take that constant to the right hand side. From here, we just need to complete the square, 2x. To complete the square, like I said, we take the coefficient of x divided by 2. That gives us 1. Then we square it and add it to both sides, like that. coefficient of y, again we take it, divide it by 2, it gives us -5, and then we square that, add it to both sides. So we're gonna add that 1 to this side and that -5 squared again to this side. And then now what do we need to do is just x plus what you have inside the brackets, which is 1, and then you square everything. Y plus what you have inside the brackets, that is -5. Y plus -5, that's y minus 5. Okay, and then the right hand side, just add everything together and then you tell us what you get. You must be getting 25. And then from here you can see the center, the coordinates are going to be -1 and +5. And then r squared equals to 25, which therefore means r equals to the square root of 25, therefore r equals to 5. Then we are done.